Kind of where we are. All right. Describe the relationship of the data on the right. Well, I have to figure out what type of correlation that be. And that be a positive correlation. If I wanted to be more specific and write a lot, which I don't want to do because, the lag on this computer has been so bad lately. I could say as the years move on, there are more snowboarding participants in the snowboarding competition. And I can see that because I can draw a nice little line that fits those points. A line that fits those points, which leads us to us talking about the line of best fit. If there's a line of best fit, can there be a best line of best fit? So let's talk about that. I'm going to get a website that we're going to use a ton ready in a second. Let me get that now. A line of fit, a regular line of fit, which we've drawn several times, is a line drawn on a scatter plot close to most of the data points. It can be used to estimate data on a graph. So I should be able to draw like a line right in the middle. I could have done a better job. Scooch that up a little bit. Your line isn't supposed to be above it. It's not supposed to be below it. It's supposed to be smack dab in the middle of as many of those points as you can get it. Same thing here. I'm not going to just put a line right there, which I put no line at all. I'm not going to put like a line right there. Okay? It's going to be a line that goes right through the middle of everything. When I take a look at the third one, I have no line of best fit because I have no obvious correlation. With the first two, I knew that I had a positive correlation because those dots are definitely going up and to the right. Even the second one, even though like it's not pretty, the dots are still definitely going up and to the right. This one, I've got nothing. So if I were asked to draw a line of best fit for that guy, I'll leave it blank because there is no line of fit. I haven't brought in the word best yet. Draw a line of best fit if you can. So again, if you have your own notes, which I emailed to you guys either yesterday or last week, if you printed it out or if you have it on your phone, you should be able to draw like a line right in the center of that, and right in the center of that, and right in the center of that. Maybe I can lower that a little bit. And I can draw a line right in the center of that. And right in the center of that. And I can't draw a line of best fit because it doesn't have a correlation. It's not even linear. How can I draw a line through something that's not even linear, guys? I'll tell you how I can't. Now this is different. Estimate an equation for line of best fit. So this is where we're going to have to remember what we're talking about. An equation of a line looks like this. An equation of a line looks like y equals mx plus b. Now we've done this 1,000 times. M stands for my slope. B stands for my y-intercept. So I'm going to try to draw a line. It starts at 0, 0, so I'm going to keep it at 0, 0, and I'm going to draw that line best that I can. It's not too bad. Now what I need to do is I need to find the slope and I need to find the y-intercept. The slope is found by looking at my graph and doing rise over run. So I look at my red line and I can put a dot right there and a dot right there. Be very, very careful. When I go up every space, I'm not going up 1, up 2, up 3. I'm going up 10, up 20, up 30, up 40. So I'm going to do that. Up 10, up 20. So my slope, and remember, I'm just going to add this in here. My slope is rise over run. My rise is 20 because I went up 20. When I go over, am I going over by tens? No, I'm just going over by 1. So over 1 is over 1. So my slope is 20 over 1. Let me get my calculator. 20 divided by 1 is 20. So my slope is 20. My y-intercept is where my red line that I create crosses the y-axis. Here's my y-axis, and my red line crosses the y-axis right here at 0. So my y-intercept is 0. So when I put it all together, y equals mx plus b is going to be y equals, instead of m, I now found out that m is 20. So instead of m, I'm going to write out 20 x plus b. What's my b? Oh, 0. Wait a minute, I don't need plus 0. So y equals y equals 20x. What this means in the real world, and let's remind ourselves about what these mean in the real world. Your slope is also the same as your rate. We've talked about that a bunch of times in chapter 4, and we talked about that a bunch of times in chapter 6. Your slope is your rate. Your rate is going to be your y-axis per your x-axis. So this 20 means that this food server earns $20 per hour, give or take. The fact that there's no y-intercept means he or she starts with nothing. Okay? That's my equation, though. Give or take, the server makes about $20 an hour. Estimate an equation for line of best fit. Okay, let's do it again. I'm going to draw a line of best fit right there. I have y equals mx plus b. M is my slope, so I don't know. I could put a dot. Didn't really draw a good line here. I could put a dot here and a dot. Let me draw a better line. It's a shame that I actually can't draw lines on here. Can I? No. All right, so I'm estimating, which is fine. So what I got in the previous problem, if you have something a little bit different, that's okay. I could put a dot here, and I can put a dot here, it looks like, according to the line that I drew. Be very, very, very careful. My slope is not up 1, 2, 3, 4. Every time I go up by 4. So my slope is up 4, 8, 12, 16. So up 16 over, is it over 1, 2, 3? Is it over 4, 8? No, it's over 3, 6, 9, 12. So over 3, 6, 9, 12, 16, 15. That's M. My B is my y-intercept, which is 0. So writing this out, but replacing M and B with these numbers, I have y equals 16 over 15x plus 0. And again, I don't need that plus 0. I don't need it. Leland's Chromebook died. Thanks for letting me know. So we have dots. We have a negative correlation this time. We have dots going down and to the right, and that guy out there. And if you remember what those guys that are floating out in the middle of nowhere are called, type it in the chat. But that's not gonna have any effect on the line. I'm still gonna draw a line right there. This is like the dumb kid in the corner that the teacher chooses to ignore. He's a bad teacher. This is what I need. I need y equals mx plus b. Let's find out what m is. So I can put a point here, it looks like, according to my line, and a point there, it looks like, according to my line. When I go up and down, I go up and down by 5, 10, 15. So I'm going to go down 5, 10. So my slope is a negative slope, and it's negative 10 over. Let me see. How many do I go over when I go over by x's? 3, 6, 9. So I go over 3, 6, 9. Negative 10 over 9. That's my slope. What's my y-intercept? It's right around there. I'm going to call my y-intercept 35. And again, if you are doing this on your own and you do a bunch of these and you're like, that's not what I got, sir. I got 36 or I got 37 or whatever. I got 34. That's fine. We are estimating an equation. We're not coming up with the perfect answer. We're not. We're taking my lines, which are not that good, and we're trying to make an equation from my lines. So I have y equals mx plus b. I'm going to replace this m with that m, which turned into negative 10 over 9. X plus b, and my b is 35. Oh, no. Graphing calculators use linear regression to find a line of best fit. I don't have a graphing calculator. I don't have a graphing. Oh, but you know what I do have? I have this guy. I'm going to paste this into the chat so you can use this website on your own when we need to. And I've given you this website a bunch of times. But remember how we would do this and this guy over here would say R? Hold on. Like, I'm just going to put in random numbers. 1, 2, 4, 6. And click line of best fit. You know how that would say R? And I would be like, I'll tell you what that means in a little bit. Now is a little bit. R is how closely your points are together. It's called the correlation coefficient. The closer your number is to 1, the stronger your correlation is. So if I'm going to put all of these dots, right? And let me actually just put another dot. Oh, you can't see what I'm doing. My bad. I'm sorry. Over here, I underlined correlation coefficient. The closer your number is to 1 or negative 1, the stronger your correlation is. So if I go back here, all right, and I'm just going to put in random points. Let me reset it. Random points. How about 0, 0, 1, up to 3, negative 3, negative 3. What else is a good one? 8, 7, 4, 5. See how these dots that I just put in here? They're pretty close together, but they're not a straight line. I can't draw a straight line connecting all of them. So what I'm going to do is I'm going to click to show the line of best fit. And what it does is it gives me a line that best fits the equation. And that equation is going to be this guy right here. That's going to be the equation of the line of best fit. The R is a number that tells me how strong the correlation is. The closer the number is to 1, the stronger it is. This is a strong correlation because the R is almost 1. So you have to compare this number to like money. All right. If you need $1 and you're collecting all of your pennies and you have 98 pennies, you're almost there. If I were to throw another number in here and really screw things up, like -80, now that really screws things up. That's an outlier. So my line of best fit changed and my correlation coefficient got smaller. If I got rid of that number, everything goes back to normal. All right, so let's find the line of best fit for this guy using the website that we have. All right, and we're just going to take turns or take our time plugging all of these into the website. So I'm going to stay on this screen. And I want you guys to, whether it's on your phone or open up a new tab in the chat, click on the website and plug those in too. All right, I'm going to stay on this screen so you can see the points to plug in, and I'm just going to go back and forth and back and forth and back and forth. Give me like 2 minutes. All right, so this is what I've got, and it's very, very, very important that you check to make sure you typed them in right. So I have 219.39. Yep. 249.50. Yup. 215, 215.36. Yup. 183.28. Yup. 282.55. Yup. Scroll down. 241.41. Yup. 263.50. Yup. And 256.48. Yup. All right. It's not a big deal, the order that you put these in, as long as the X and the Y are matched together. So my line of best fit is going to be Y equals 0.28X minus 22.88. So let's go back here. Line of best fit is Y equals 0.28. I forgot the rest. 2288 minus 2288. And my correlation coefficient, my R, is 0.98 again, which means pretty close. These dots are pretty close together, pretty strong. If this was negative, it would be a negative strong. Oops, I forgot an X. Fun. Goals. Hashtag relationship goals. Am I right, students? Hashtag goals. Estimate an equation for line of best fit using Lin Reg. Ugh. Well, I mean, I could have drawn a line there, but it's telling me I have to use Lin Reg. Well, here's the key word, estimate. I'm going to make a chart of X and Y values, and I'm going to estimate what those points are. Okay. My first point is going to be 2012, 1200. So 2012, 1200. Lin Reg, by the way, if you're like, Lin Reg means linear regression, which means we're using a calculator or the internet or whatever computer that we need to do. All right. The next year is going to be 2013, and 2013 is a little bit less than 1200. So we'll say 2013, we'll say 1150. The next year is 2014, 1000. The next year is 2015, a little bit less than 1000. So we'll say 2015, a little bit less than 1,950. We're estimating. The next year is 2016, and that's pretty much right in the middle. So we'll say 900. 2016, 900. And then the last year is going to be 2017, and that's also right in the middle. So we'll say 700. Back to the website we go. Back to the website we go. I'm going to clear, reset. I'm going to go back here and plug those points in. I have 2012, and I'm going to leave it on this screen for those of you who need to see it. And I'm just going to go to my website, 2012, 1200, and I'll just quietly do that. All right. I got all my points in. No mistakes. Line of best fit is y equals negative 94.29. So y equals negative 94.29x. Ugh. I'm definitely going to run a space. Plus 1909219. 190.9 to 1.9. Yep. And if you're wondering, what about R? Well, it doesn't say we have to write down the R. But R was, if just out of curiosity, R was negative 0.98. Negative. Why is it negative? Well, because that's a negative slope. Negative 0.98 is almost negative 1. Again, if you're thinking of money again, 98 cents is awfully close to $1. And so these points are really close to each other. Really close. Estimate an equation for line of best fit using LinReg again. So you know the drill. I'm going to leave this screen up. Now, if you're confused, like it's sideways, if you're like, oh, how do I put it regular? Your X's are always on your left and your Y's are always on your right. So the first point right here would be 1 and then 420. And then the next one would be 2 and 500 and blah, 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 blah. I don't have to do that if you know what you're doing, but if you need to rewrite it out, go ahead and rewrite it out. But I'm going to go to my website and I'm going to type them. I'm going to type those Johns in. I'm going to type those Johns in. I'm going to leave this screen up. Okay, this is where I'm at. Line of best fit. Y equals 272.14 minus 72.14. Can't get much prettier than that. 272.14x. And then what was it? 72.14? Yo, that's crazy, yo. Yo, that's crazy, dog. Yo, that's crazy, yo. My correlation coefficient was 0.97. How many more do I have? Oh boy. Let's see how many of these real world problems I can do. Find an equation for the line of best fit. Identify and interpret the correlation coefficient. All right, so I need to identify the line of best fit. So let's go back to our website. I have 94.72, so I'm just going to type them in. All right, so whoopsies. I added my points. I got y equals 0.77x minus 1.1. So A is find the line of best fit. Y equals 7.7. What was it? 0.77x. Oh, my bad, dog. Y equals 0.77. It was a minus 1.1, minus 1.1. Identify and interpret the correlation coefficient. The correlation coefficient was a perfect 1. When it's a perfect 1, that means this is a straight, perfect, straight line. The closer it is to 1, the closer it is to being a straight line. When it is 1, it is a straight line. Interpret the slope of the line of best fit. Slope means rate and it's going to be y per x. Slope means rate, and it's y per x. My slope is 0.77. Y is milligrams per pound is LB. So this person's there. This is about medicine. So you have 0.77 milligrams per pound. That's what the slope means. A patient who weighs 140 pounds is prescribed 135 milligrams of medicine. How does that affect the line of best fit? So let's go back to it. Let's go back to our website and let's put in that point. A person who weighs 140 pounds is prescribed 135 milligrams. So the weight is an X, so 140 is prescribed 135 milligrams. So what did it do to our line of best fit? It changed it. I feel like I typed in something wrong, didn't I? 140, 135? No, I typed it in. It changed it. It changed it quite a bit. So the answer to C is it changed it. Let's do one more. We have time, enough time just to do one more. Okay. Here's our data. I'm going to leave it up. I'm going to plug it in as fast as I can. All right, so I typed in all my points. I typed them in correctly. Here I am. The line of best fit is negative 0.51x plus 60.54. y equals negative 0.51x plus 60.54. So what are we doing here? The table shows the daily temperature and the number of hot chocolates sold. All right, so interpret the slope. That's my slope. That's my slope. So the warmer it gets, you sell. We're not going to have time to write it out. The warmer it gets, the less hot chocolate you sell, and you usually, that is how many you would sell if your temperature was 0. Oof. It's a cold day. All right.